So in our example here, we have C plus A is equal to 80. Okay, the amount of cashews plus the amount of almonds is equal to 80. That's the total number of pounds. So let's say we're going to solve for C. Okay, C equals 80 minus A. So you're going to plug that back in, 80 minus A, plug it back into the C. Then you can solve for A, and then you would solve for C. And you say, if you solve for A first, you plug it in, 80 minus A in for C here. You do the math, you multiply that out. A is going to equal to 60. And then if I plug A is 60 here, C is going to be 80 minus 60. C is going to be equal to 20. So my final mixture here, a mix of 60 pounds of almonds and 20 pounds of cashews will give me $580 worth of this mixture. When you're solving word problems, of course, we want to read the word problems very carefully. Plan by making a table. We made tables in the last section, and you're going to want to make a table again. Then you solve a system of equations obtained from information in the table. You would plug in your numbers into the different sections of the table, and then that will help you to solve the system of equations. And then you check your answer, and check your answers to make sure that you have it correct. All right, let's take a look at another example here. Okay, example number 2. This is on page 314 in your book. The problem says, Emmanuel Christian School sent out 150 pieces of mail. Some required 60-cent postage, while others required an 84-cent postage. If the total bill was $108.48, how many pieces of each type were mailed? So then we have to define our variables here. We have X and Y. So we have two different types of stamps, right? The 60-cent stamps and the 84-cent stamps. So we can have X equal the 60-cent stamps, and then Y would be equal to the 84-cent stamps. The total they sent out was 150 pieces of mail. Now, the price per item $60 for the 60-cent stamps, and then $84 for the 84-cent stamps. Basically, they multiplied 60 cents times 100. That's how they got 60. Then 84 cents would be 84 times 100 is 84. The total cost is you take the pieces times the price and you multiply it together. Then that's going to give us 60x, 84y. And what was the total bill? The total bill was $108.48. But we want to multiply by 100 to get rid of the decimals. We end up with 10,848. If you take the pieces, okay, we have X plus Y. The total number of pieces is 150. Then we take the cost. The total cost here now is 60x plus 84y is equal to 10,848. All right, so first you read through the problem and you carefully assign the variables. We set up this chart right here, the table. and organized all of our information. So we used cents instead of dollars. So we converted, this is 60 cents instead of $0.6. These are cent amounts, okay? Then that way you don't have the decimals anymore and you don't have to deal with the decimals. Now, our equation, the pieces was x plus y equals 150. The cost was 60x plus 84y equals 10,848. Then, if you solve for x, okay, let's say we have x equals, here you have to move the y over, subtract, so x is equal to 150 minus y. Then you plug that back in to your x right here. 150 minus y, okay, that's your x, but you've got to use the distributive property, multiply 60 times 150, and then 60 times y, and you have plus 84y is equal to 10,848. Then you can solve for y. You're going to have to work out, and you actually see that in the example in your book. You end up with 24y plus 9,000 equals 10,848. When you solve for y, you get 77. And then if you subtract 150 minus 77, that's how we get 73. Again, take a look very carefully in the example in the book, and then you'll be able to see how x is equal to 73 and y is equal to 77. The school mailed out 73 pieces of mail at the cost of 60 cents, that's our x, and 77 pieces that cost 84 cents, that's the y. These mixture problems, some problems involve combining two mixtures of different strengths in order to get a final mixture of a desired strength. So kind of like the cashews and the almonds. Cashews cost more than the almonds, right? So we had to mix the two different nuts and you get the final mixture. And now we're going to look at some examples that have to do with strengths in the mixture. Okay, so we're going to talk about some solutions with water and salt. Okay, adding pure water is like adding 0% salt solution. Adding pure salt would be thought of as adding 100% of a salt solution. In example number 3, if you read this carefully here, it says if milk that is 3% fat is mixed with fat-free milk to produce 5 gallons of 2% milk, how much of each should be used? And I'm sure some of you would drink 2% milk, some drink whole milk, some drink fat-free milk. Okay, so here they're talking about what amounts of the 3% and the fat-free can we mix together in order to get a 2%. So you have to first define your variable. X can represent the 3%. Y is going to represent your fat-free. Then the total amount, we want 5 gallons of 2%. Now, the percent of fat in the 3% milk, if you convert that into your decimal, it's 0.03. The fat-free is 0. And then the 2% is 0.20, or 0.02, sorry, 0.02. So we read through the problem, and then we distributed our information into this chart right here. And the number of gallons times the percent of fat is going to give us the gallons of fat right there. So that's going to be 0.03x. Y is going to be 0 because the fat-free milk is 0. But your 2%, you want to see how much of each should be used here. The difference between, oh, okay, let's keep going here. The gallons, we have x plus y equals 5. Okay, now the amount of fat, we've got 0.03 and 0. 0.03 times x is equal to 0.1 right here. The 2% is at 0.1. Now, how did we get that? Okay, because the y is 0. And then so we just have 0.03x is equal to 0.1. Now you solve for x. If you divide, you'll get 3 1/3%, or 3 1/3 right here for x. Then if you plug 3 1/3 here, and you solve for y, 5 minus 3 1/3 will give us 1 2/3. So 3 1/3% of the 3% milk should be mixed with 1 2/3 gallons of the fat-free milk. That will produce 5 gallons of 2% milk. Those are your proportions right there.